There are moments in mobility design when a vehicle stops behaving like transportation and begins behaving like architecture. What stands before me here is not merely a motorhome concept, but a redefinition of spatial mobility, a study in how residential architecture, aerospace streamlining, and long-haul engineering might converge into a singular speculative platform. Before we go further, it is important to frame this correctly. What I am examining is a fictional AI-generated concept, a forward-looking design exploration intended purely for imagination and analytical discussion. It does not exist physically, nor is it a production vehicle. And yet, the sophistication of its execution invites serious engineering interpretation. From a proportional standpoint, this motorhome appears to stretch approximately 45 to 50 feet in overall length, with a height approaching 15 feet at the upper roof canopy. The width looks to be near the maximum allowable highway envelope, likely around 8.5 feet for road legality in a theoretical real-world context, though the expanded terraces clearly push beyond that when deployed. The wheelbase configuration is particularly telling. We observe a multi-axle setup, 3 rear axles and a forward steering axle, suggesting a quad-axle architecture engineered for distributed mass management. Given the double-deck structure and the visible rooftop garden mass, this configuration would be essential to handle vertical load concentration while maintaining predictable highway stability. From a structural engineering perspective, this suggests a reinforced ladder frame or potentially a modular aluminum superstructure beneath a composite superstructure. The length-to-height ratio indicates careful attention to center of gravity control, especially considering the extensive glazing and rooftop occupancy. Now, let us consider the exterior surface language. The front fascia is unmistakably aerospace-inspired. The glazing wraps dramatically across the nose in a continuous, visor-like canopy, eliminating the traditional segmented windshield geometry seen in conventional RV architecture. This suggests a laminated structural glass panel with integrated reinforcement ribs or embedded composite support frames. The aerodynamic logic here is intentional. The nose tapers gently forward, eliminating abrupt vertical planes, and transitions into a softened curvature that encourages airflow to remain attached across the body. This would significantly reduce pressure drag, one of the primary inefficiencies in traditional box-style motorhomes. The surface tension modeling is fluid and continuous. There are no harsh panel breaks interrupting the shoulder line. Instead, a sweeping, ribbon-like character line begins at the headlamp cluster, travels along the mid-body, and dissolves toward the rear. This indicates a design philosophy rooted in monocoque visual integration rather than modular assembly. The paint finish appears to be a satin metallic silver with high reflectivity but subdued gloss. This type of finish would likely incorporate ceramic nanoparticle layering to improve UV resistance and thermal rejection. In high-altitude sunlight, as the landscape here implies, thermal management of such a large body would be critical. Observe how the ambient sunset light diffuses across the curvature of the front quarter panels. The reflection gradients reveal subtle compound curves rather than flat surfaces, suggesting Class A surfacing discipline, the same surface refinement standard used in top-tier automotive design studios. The lighting identity deserves particular attention. A continuous blue LED light band traces the upper front fascia and extends into the side architecture. This is not merely decorative. In a plausible engineering context, such a lighting strip could function as adaptive daytime running illumination combined with sensor housing integration. The headlamp clusters below appear sharply angled, suggesting matrix LED or even laser-assisted beam technology in a theoretical build. The layered light architecture creates a hierarchy: primary beam modules recessed, signature light blade exposed, and secondary accent lighting integrated into the body seam. This layered lighting strategy enhances perceived width and lowers the visual center of gravity. For a vehicle of this height, that is psychologically significant. Now, let us address the glass-to-body ratio. The upper deck is almost entirely transparent. From an engineering standpoint, this introduces considerable structural challenge. Large, uninterrupted glass spans require reinforcement through hidden carbon fiber frames or structural steel pillars concealed within slim mullions. The tint density appears moderate, enough to manage glare but not so dark to compromise panoramic views. Electrochromic smart glass would be a logical inclusion in a concept of this ambition, allowing variable opacity based on sun angle and interior thermal load. The rooftop environment introduces an entirely different layer of design ambition. This is not simply a roof terrace, it is landscaped. Vegetation integrated into a moving vehicle raises immediate weight and irrigation questions. In a speculative engineering scenario, one could imagine lightweight hydroponic planters using recycled gray water and automated drip systems. The canopy structure above appears cantilevered with minimal visible support columns, indicating a reinforced carbon composite roof beam structure distributing load laterally. The canopy itself is thin and planar, evoking modernist residential architecture rather than automotive precedent. Its overhang would provide solar shading while potentially housing flexible photovoltaic cells embedded within its upper surface. Turning to the midsection, we see a dramatic cutaway terrace opening along the lower deck. This suggests a deployable slide-out mechanism on an entirely new scale. Traditional RV slide-outs extend horizontally. This concept appears to create a full-height open-air pavilion. The structural implications are profound. Removing that much sidewall area would require a rigid exoskeletal perimeter frame to preserve torsional integrity. Otherwise, highway flex could compromise sealing and alignment. The triaxle rear arrangement reinforces the idea that this vehicle is engineered around load stabilization. The wheel arches are sculpted but understated, housing large-diameter rims likely optimized with partial aero covers to minimize turbulence. Tire sidewalls appear relatively low profile for a motorhome, suggesting highway bias rather than off-road orientation. Ground clearance is moderate, adequate for graded terrain but not extreme overlanding. This is a luxury mobility platform designed for curated destinations, not wilderness conquest. The rear identity, though partially obscured in this angle, appears clean and symmetrical. There are no aggressive diffusers or exposed mechanicals. This restraint reinforces the architectural thesis. From a design philosophy standpoint, this concept leans heavily toward marine superyacht influence combined with high-end modernist hillside villas. It redefines the RV segment by abandoning the utilitarian aesthetic entirely and embracing a language of curated minimalism. Who is the intended user archetype? Likely a mobility-oriented executive or creative visionary who values space, visibility, and architectural presence over rugged practicality. Is this evolutionary or revolutionary? Architecturally, revolutionary. Structurally, it would require evolutionary advances in lightweight composites, smart glass, and chassis rigidity. My first professional impression is that this is less a motorhome and more a thesis statement on what long-range residential mobility could aspire to become when freed from manufacturing constraints. And that brings us inside. Even without full interior schematics, the exterior massing allows us to logically reverse engineer the interior architecture. Given the height and window placement, this is clearly a dual-deck layout with an open rooftop lounge. The lower deck likely houses communal living functions, lounge, dining, and galley. The upper enclosed deck appears optimized for panoramic seating and private quarters. Ceiling height estimation suggests approximately 7.5 feet on the lower level and slightly reduced clearance upstairs due to roof taper. To maintain structural rigidity, load paths would run vertically through reinforced pillars aligned with axial load distribution. Sleeping quarters would logically be positioned toward the rear upper deck, where road noise is reduced and privacy maximized. Acoustic insulation would need to combine multi-layer foam composites and vibration-damping subfloor panels to counteract diesel or hybrid drivetrain resonance. Kitchen engineering presents its own challenge. In a real-world build, weight distribution would require centralized water storage tanks positioned low and between axles. Appliances would need to be induction-based to reduce open flame risk and energy inefficiency. Energy consumption for such a structure would be immense. A plausible system might combine hydrogen fuel cells with a high-density lithium-silicone battery pack. Solar contribution from the roof canopy could realistically supplement auxiliary systems but would not fully power propulsion. Water recycling would be